like this. Yay, this is good stuff. So I can actually get it in there. There it is, right there. Rational functions. So rational functions, what are the first 5 letters of rational? What are the first 5 letters? Ratio. So it's a ratio of what? A rational function is a ratio of 2 what? Anybody want to guess or can read that what it says up there? Ratio of 2 polynomials. 2 polynomials. So for example, is this a rational function right here? Is that a ratio?
Oh, yeah.
Yes, it is. It's a ratio. It's something over something. Any fraction is a ratio. Is the numerator a polynomial?
No.
Yes, it is. Is the denominator a polynomial?
Yes.
Yes, it is. What can't you have in the equation for it? What would happen? How would you make it not a polynomial? 0, that's a noun. I need a sentence with like a verb would be good. Okay, so we need to remember what a polynomial is. Okay, a polynomial is something that is made up of terms that look like this. Like a sub n, and if I could get this to erase, it's being a little ornery today. It looks like this, a n x to the n, where right there you can have any real number. And what can n be? What kind of number does n have to be? Anybody remember? A whole number? So what can't the power be? What can't the power be? Negative, like -5, right? So once again, both the numerator and the denominator are polynomials, so it's a rational function. What about this one right here? Is that a rational function? Is the numerator a polynomial? Yep. Is the denominator a polynomial? Yeah. So is this a rational function? Yeah. What about just x over y? Yeah. Not really. It's in 2 variables, so no. You could say no. It's a different type, but yeah, no. So they're elements of the set p over q, where p and q are polynomials, where q can't be 0. Why can't q be 0? Because you cannot divide by 0.
Yeah.
Because you cannot divide by 0. Exactly. Right. So we're going to be working with. So for example, I'll just ask you. You can figure out the definition of domain by telling me what's the domain of this one right here. What's the domain of that rational function? That is a rational function. What's the domain of that function? I've asked you this. We've covered this. So take a stab. It's okay if you're wrong. What is the domain of that function?
Anything that's not 5.
Anything that's not 5. That is correct. All real numbers except 5. Why can't you have 5? Because if you put 5 in, it would create a 0 in the denominator. Exactly. What about a here? What about a, Connor? What about a? What's the domain of that one? X such that x can't be what?
2.
Correct. This means right here, that in blue means x such that x doesn't equal 2. That's what it means. So that bar means such that. Okay, well let's up it a little bit. What about this one right here? First of all, let's go with gray. Is this a rational function? Is b? Is that a rational function? Yeah, it is. Can someone tell me what you have to do first in order to figure out the domain of that function? Factor first. So can somebody factor the denominator in their head for me and tell me what it's going to be? It's going to be 3 plus x over what? Can anybody factor that for me? Raise your hand if you think you have it. Raise your hand if you think you have it. Yeah, Harry.
X minus 3 times x minus 1.
Correct. Nice. So can you tell me what the domain of that function is? Except for 3 and 1. Exactly. Good. You just factored to find the domain of another one. Okay. Factoring is something you're going to do first quite often in this section. Quite often. Yes?
Would it also be except for negative?
Nope.
Because the x on the top.
Doesn't matter. Can something equal 0?
Yeah. Oh yeah.
Absolutely. No, it's a common thing because you're looking for zeros that you don't want 0 to be anywhere. It's totally okay for 0 to be in the numerator as long as it's not also in the denominator at the same time. Like 0 over 0 is just as indeterminate as 5 over 0. So can you plug in -3? Sure. It's going to be 0 over something, right? Not 0. What are the only 2 values that make the denominator 0? 3 and 1, not negative 3. Milo, what about the next one? Is this a rational function? Yeah, it is. What's the domain of that one? Can anybody help him? What's the domain of that one? All reals. Is there anything that makes the denominator 0? No. So the domain of that function is all real numbers. Okay, here's one that's a little bit more challenging. What about this one right here? First of all, is that a rational function? Yep. What's the domain of that one? Yeah, Mar.
All real numbers besides 2.
You sure? Can you plug in 2?
Well,
Can you plug in 2?
well, isn't x squared plus 4?
Can you plug in 2? What's 2 squared? What's 4 plus 4? So when you plug in 2, you get 2 over 8. So can you plug in 2? Yes. That one is all real numbers because look, x squared plus 4, can that equal 0? Is that possible? No. Because x squared, can x squared ever equal negative 4? No. X squared plus 4 is always what? Greater than or equal to what? What's the smallest x squared plus 4 can be?
0.00.
Nope. Nope.
4.
4, exactly. The smallest it can be is 4 because x squared is always positive. So what's the smallest x squared can be? 0. What's 0 plus 4?
4.
Can 4 ever equal, if you're stuck at 4, can you ever get to negative 4?
No.
So I have to be careful. So if I ask you for the domain is the set of all valid inputs. So domain is going, you could say, all valid input values. And generally speaking, what are the input values called? The what values?
X.
The x values, generally speaking, in this class. Okay, so let's actually work with more mechanics inside the world of rational functions. And to do that, we're going to use this rule over and over. And you've used this a million times already. You've already used this rule tons and tons and tons of times. Here it is. It's this fundamental property of rational numbers. It's a lot of words basically to say this. If you have a over b, that's the same thing as a over c over b over c. Can you go in both directions? For example, if I gave you this, what would you do to simplify that? No, you won't multiply anything. What would you do to simplify this right here? Cross out the c's. Thank you. You would just cross out the c's. This rule, this fundamental property of rational numbers, allows you to simplify things that have common factors in the numerator and the denominator. So, for example, you have these potential things to simplify. What's that first thing you're always going to try to do, if you can? Yes, simplifying is what we're doing, but what's the first thing? Step 1. Step 1. Step 1. Factor. Good. When I point at things, sometimes you see them. This word right here is super important. Factor, 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 factor. Generally speaking, is it easier to work with something that's factored or unfactored? Factored. Usually it's much easier to deal with something that's factored, right? Like I could write a number that's 100 digits long, or I could write it in factored form. What would you rather have, the factored form or the 100 digits? The factored form. Is it sometimes hard to find the factored form? Yeah. So what's nice about A? Can you tell me what's nice about A? It's factored already. It's factored already. So can we cancel anything there? Milo, what could we cancel on A? What could we cancel?
The x.
Nope. You can't cancel an x. You can cancel the...
X plus 2.
Yeah, you can cancel x plus 2 and x plus 2, leaving you with x plus 5 over x minus 3. Is there anything else we can do to that? No. There's nothing else. What about B, though? What's the challenge? What's the one more thing added in for B? No, you cannot, because it is not multiplication. It is x plus 5 and x minus 3. You cannot cancel anything else on that. What about B? What do you have to do first on B? Factor. So do that for me right now by yourself. Factor and simplify B and C. Factor and simplify. What's the factored form for B? Anybody have it? Nick, what is it?
For B, I got
A
minus 3
times
over,
times
A plus 2
plus 2. Yep. Over.
A plus 3
Yep.
times A plus 2.
Exactly. So what cancels?
A plus 2.
Yeah, the A plus 2's cancel, leaving you with just what?
A minus 3 over A plus 2.
Correct. And you're done. Good. Who can tell me about C? Who can tell me about C? Who factored C for me? Mar, what'd you get?
For the top, we got y plus 2
Times.
y minus 2.
And then what did you get for the bottom?
2 and y plus 2.
Yeah, so what cancels?
Y plus 2.
Leaving you with just?
Y minus 2 over 2.
Correct, and you're done. Nice. Excellent. What about D? Can you just look at D even if you haven't done it and tell me what do you notice about the top? What do you recognize in the top? Difference of cubes. Does anybody remember what that factors into?
Yes.
X minus 3 times,
X squared plus negative equals 2.
isn't it, is it
It's minus.
minus 3x plus 9, right? All over x minus 3. Now, is there something that cancels? Oh, look! So what are you left with? Just this. Done. If you remember the difference of cubes, you're done. Yeah, Liv. Yeah, go ahead.
I don't understand how you got that. Wait, never mind.
You got it?
Yeah.
Okay, so, yes, Harry?
If you factored the one on the bottom.
This is great. So what should it be? It shouldn't be this. It should be like that. Now, does that work? The fun thing about the last one, can you simplify that? Can you tell me the number one way people simplify that wrong? What do they do? Yeah, can you do that? No, you cannot because of the plus sign. So is there anything you can do to simplify that? No, you can rewrite it. You could say that's 8 over 16 plus k over 16, which is 1/2 plus k over 16. But what's the number one thing people do wrong on this? They go, I make that a 2. Is it equal to k over 2? No, it is not. So this one right here, stop. There's nothing more I want. Store, if I could write stop. Don't do anything else on this. Do not do anything. Look at that. Can you cancel anything there? No, because they're not the same thing on the top and the bottom, right? Do you agree with that? So let's examine this for a second. Let's just examine this. This is equal to, what's another way to write m? Negative 1 times negative m. What happens when you multiply negative 1 times negative m? What do you get? Okay, minus, or plus, how about this? Plus minus 1 times 3. Have I changed anything about the numerator? Have I changed anything? No, I haven't. And let's just keep the bottom the same. What is in this and this? What's now in both of those? Negative 1. So what can I factor out of both? So negative 1 times what? Negative m plus 3. And what's still in the denominator? What's another way to say negative m plus 3? So you have negative 1 times 3 minus m all over what? Not plus. What? It's an equal sign, sorry. Over what? 3 minus. Oh, can you cancel something now? Oh, this goes away. What are you left with? What's 2 minus 5? What's 5 minus 2? What's 7 minus 4? What's 4 minus 7? What's 12 minus 7? What's 7 minus 12? What happens when you switch the order of subtraction? It just changes the sign. Does it change the value? It only changes the sign to the opposite of what it was. So what this means, a minus b over b minus a, what does that always equal? Negative 1. That always equals negative 1. It always equals, and this is the kind of the proof for y right here. But the idea is a minus b is equal to negative b minus a. That's the truth of the matter right there. That's another way to write it. Just something to remember in your head.
Negative b plus a?
No, it's not. Because what's negative? That would be negative b plus a, which is a minus b. They're the same thing, you see? Yeah, absolutely. So there you go. So let's factor. What's the first thing you notice that can be factored in this? Oh, come on. I see two things that could be factored. What can I factor?
The numerator and the first.
Yeah, what does that one factor into?
5p minus
5 times p minus 1 over p. You can't really factor 3p squared. Oh, but what can I factor on the bottom here? 10. So what do 10p minus 10 is what can be factored. What can I factor out of that? Yeah, so what am I left with? 10 times what? Now, is there something that cancels? Because it's all multiplication. Because it's all multiplication, what can I cancel? What am I left with now? 15p squared over 10p. Am I done? No. What is one thing I can do to simplify that? You could cancel, yeah, you could cancel this. So what does that become? 15p over 10. And what else can I do?
Simplify.
Yeah, so what's that going to be? 3p over 2. Do you have to do all the simplifying in the same step? Did I do all the simplifying in one step? No, break it down. Do one thing you know is true, do the next thing. Is any step here super complicated? No, it's not. But what happens? People try to do 3 things at once, and then they flip the 2 and the 3 or something like that, and then all of a sudden it's not correct. Just take it slow. So someone tell me, what does this one factor into? So this is going to be x minus 6 times what? X what? X plus 3 times x. Nice. Kids, what does this one factor into? Someone tell me that one. Times? Yeah. And what about this one right here?
X plus 3, x plus 4.
Excellent. Don't do a bunch of things now cancel? Absolutely, they cancel. So you get x minus 6, x plus 3, x minus 6. What's the only thing you're left with? So it's going to equal 1 over x plus 4. Very good. Very good. Each of you factor your 1. Numerator on the first one. Who did the numerator on the first one? Was that your group, Connor? What is it? What is it?
5n minus 3.
Yep. Nice. And what about the numerator on the second one? Who's got that? What do you got, Milo?
5n minus 3, 5n, no, n plus 1.
Plus 1? Yeah. And then what's the denominator on the first one, Nick? 3m what?
3m minus 5.
Yep.
N plus 4.
Sounds right. And then what about the denominator on the second one, Obs?
5n minus 3.
Yep.
3n minus 5.
So you get a lot of things, and hopefully a bunch cancel. Only a few things cancel, though, right? You have 5n minus 3. Yep. Which one? What be flipped?
The stuff on the right.
The stuff on the right. Oh, I didn't flip these yet, did I?
No.
Good catch. So those right there should be where? Ah, so this should be right here. Good catch, because it's division, right? Woo! So what cancels now? Oh, that cancels. Anything else cancel? M plus 4s, right? Mm-hmm. Do the 3m minus 5s cancel?
Yeah.
Like this? So what are you left with?
5n minus 3 over n.
Ah, so actually remember that we did this wrong yesterday in the other class, so yay. That's a lot better than the answer we came up with. Okay, so here's the thing. Just because you simplify something doesn't mean it's always going to be as nice as that. Sometimes you're going to have to work a little bit. Yeah, and if it's division, what's the only thing you need to do? Flip it.